Okay, now we're going to talk about our fourth module, which is simulation. I'm here with my services colleague, Dr. Daniel Leutz, and we're going to talk about brown part stability, orientation, and sintering simulation.
Hi, James. Yeah. As James already mentioned, I'm from the service team. We are supporting our colleagues from the metal filament. What we offer is that we are simulating those filaments in the different processing stages. So as you said, first one is debinding simulation, checking the brown part stability. As you already mentioned, the brown part is quite fragile during debinding, and it could be the case that it will collapse during this its own weight.
Like we saw in this one, where we wanted to minimize the print time through using less support, but we run into that danger zone where you start getting cracks. And that's when we bring a complicated part, or sometimes even a simple part, to Daniel here to simulate and inform us how to make the design ready.
So if we look in the simulation to that part, which was printed without support and debind without support, you can see here that some critical stresses will occur. So like we see here, it will fail. But on the other side, as we simulate that with support, as we did it with here, you can see that the stresses are much lower, so the survivability of that part is much better.
And it also informed us to add other features like a larger lip on the bottom, used mostly or also for fixturing, but also to provide more adhesion to the bed while printing. We were having a little bit of warpage and things like that, and those are situations that it can assist us fine-tune our parts to really make it ready to go.
Yeah, definitely. I can help and support you and also the customers. But for customers who have the ability to do their own simulation, we have a white paper now on the homepage which can be downloaded to explain the steps how to perform such a stability analysis for the brown parts.
And rest at ease, this isn't some very super complicated thing that takes a doctor to do it. It works on SolidWorks or Inventor or NXCAM. Most regular CAD softwares do have simple simulation systems, so there's a gravitational simulation just to show the problem areas, the critical stresses on where your part can be. And that can inform you to iterate your design to have it most confident for surviving the debinding and sintering process.
Yeah, and based on that simulation, what we also offer is an orientation optimization. It's obvious for that part how you place it in the debinding oven, but it could be that you have some more complex parts which it's not obvious which is the perfect orientation. In some orientation, the part might fail. Some other orientation, the part will survive. So we have an optimization method which determines the perfect orientation which has the highest survivability of the part.
And one thing we often see, and you're probably seeing yourself, is that you're getting parts that aren't designed for additive yet. We're not thinking additive yet, like we talked about in our design guide section. Often they're adapted from a CNC milling or an injection molding or any type of manufacturing process. So being confident that you're printing it in the right orientation for the part you need is very critical. And that can enable, through our orientation simulations and brown part stability, to make sure that you're getting the first part right. Kind of good practices to lead you up to the actual debinding and sintering are critical.
Yes. And we've got a third part, which you also mentioned, is the sinter simulation. I would say sintering is the most critical and most complex part of the whole processing. And as you said before, we have during sintering a high anisotropic shrinkage. If it's a symmetric part, it often shrinks homogeneously. But if you have a more complex part, something like that, you can see on the, how the tires are aligned, you also get some warpage. Here we have set up a unique sinter simulation which predicts the shrinkage and also the warpage. As you can see here for your part, and see how it shrinks, that we also have some warpage in there. Yeah.
When you have a part where it's going to end up curved like that, we will enable you to print it where it's going to be. You're kind of shooting where the target will be when it's in sintering. So that way, it might look a little strange, like it's kind of too far this way, but we know it's going to rest down to where it needs to be. Kind of, it doesn't really matter what a part looks like off the printer. It matters when it's metal.
Yeah. And for that, we have the Sinter Optimization. Means we can predict, based on the Sinter simulation, how your green part needs to be printed such that at the end it will shrink and warp to the desired geometry. You can see it here. Now we have a different green part, but if it sinters to the right geometry. And this is a service we are also offering to our customers, but this is done by us. So approach us, and we can help you with the sinter simulation and also optimizing your part for near net shape.
And this is how we're pushing the technology literally to the limits. Through using these simulations, through using orientation simulation, we're able to print and produce parts that were unimaginable years ago, even with inside the metal filaments group. So we really want to appreciate the work from our colleagues and services, and to get you the part that you need. On behalf of myself and the rest of the Forward AM team, I'd like to say thank you for watching this tutorial. And if you have any questions or comments, please contact our sales team. Thank you.